Question number 6. You're given a DiffyQ, and this is the real question 2018, what they had to answer. So you're given a DiffyQ, and you're asked to first graph the solution of that DiffyQ on a slope field that's already been done. So it says sketch the solution curves that passes through the point 0, 2. I can find where that is. And sketch the solution curve that passes through 1, 0. So there's two ones we have to do. So here at 2, what I want you to notice is this, that it's a horizontal line. So usually that's a turning point. But I want you to look, what direction to the right and left are we going? And the answer is it's not going up or down. It's just going to be a horizontal line. So the first one, can you draw a solution curve here that goes through 0, 2? So you start at 0, 2, and you look, where is the river going? If you look at the current, where is it guiding you? Where, if you put a little piece of log down, where is that going to float to? And if I start at 0, 2, you can see it's going to float directly right and directly left. That it's not going up or down in any way. So that's the first one. The second one is through 1, 0. So can you find where 1, 0 is? It's there on the right. Now look at it. So what's happening as you float to the right? So can you get a sense of the direction of what's going to happen? So if you follow that to the right, what's happening? So can you see that following the flow? What's happening to the left? You can see the slopes are going down. Now, when you actually hit here, where there's horizontal, it's going to turn. So that creates a turning point. So it's going to turn, and then again, follow the slopes up and have a sense of what it looks like. I know it takes some time, but if you relax your brain and let the flow of the slopes guide you in both directions in practice, there it is. So you then did both the solutions, one for 0, 2, and the other one for 1, 0. Part B, can you, it says let y equals f at x be a particular solution to the DiffyQ with the initial condition f at 1 equals 0. Write an equation for the line tangent to the graph y equals f at x equals 1, and then use the equation to approximate. So for this one, we're doing a tangent line. So I'm going to do that on a separate piece of paper right here. And I know if I'm doing a tangent line, I'm going to start with what the x value is, what the y value is, and what the slope is. So what do I know? I know the x value is 1, and I know the y value is 0. The slope, well, that's the DiffyQ. So that's 1/3, and it's x times y minus 2. So the x is 1, and then y minus 2, the y coordinate is 0, and you have the value there. So this is going to be 4 and over 3 when you simplify it. Now you have what you need. So the equation of a tangent line is going to be y equals 4/3. X minus 1, we don't need plus 0. It's right there. Then it says take that one and estimate what it is for 0.7. Again, we don't need to simplify this. Plug in 0.7 and it's done. So can you do a equation of a tangent line and then plug in 0.7 and get your answer? Again, there's no need to simplify it from there. 6C, last one. So here's the big one. Can you find the particular solution of the DiffyQ with that initial condition? So can you separate the variables and solve it algebraically? So let's do that together here. So we start with the DiffyQ, dy by dx equals 1/3 x y minus 2 squared. So step 1 is, can you separate the variables? Here's the video. So do that. I'll do that too. So 1/3 x, I'm going to keep on the right side. I'm going to multiply by dx. So now they're together. I'm going to divide by y minus 2 squared. And now they are separated. Step 2, can you integrate both sides? So to integrate y, I want you to understand this y minus 2 squared. We can write that calculus friendly by to the negative 2. And then you can just do the anti-power rule. So it's not a logarithm. Here, there's no chain involved. The derivative of y is 1, so there's a 1 in front, so we're good to go. So the anti-power rule is we're going to add 1, that's negative 1, and divide. On the other side, we're all going to do the anti-power rule again. We're going to add 1 and divide, and then the constant. So we're going to simplify it, and then we have a point to plug in to find what the constant equals. So this, now I'm going to go back and write it so the algebra might be a little bit simpler. So I'm going to write this as negative 1 over y minus 2. So y minus 2 to the negative 1 just means it goes in the denominator, and this whole fraction is negative, so that's why it's written that way. This, to put it together, is 1/6 x squared plus c. And now, at any time you could plug in to solve for c and then solve for y. So let's say we want to plug in right now to solve for c. We can do that. So what's the y value again? And the y value is 0. Oh yeah, and what's the x value? It's 1. And can you solve for c? So it's positive a half, so notice the negative divided by a negative. 1 squared, and that's 1/6. Subtract 1/6 to the other side. You could do this. So if I'm subtracting, I need common denominators. So I'm going to multiply by 3 top and bottom to get common denominators. So that means 3 take away 1. You do not need to simplify. This is 2/6. Leave it that way. Then let's put it all together again. So over here we had negative y minus 2. So go back to the point where you plugged in. So we have to go back to here. And then where there's a c, we now know c is 2/6 or 1/3, whatever makes you feel better. And now I still need to get y by itself. So what's a way we can get y by itself? So this is what I would do. I would write the right side as 1 fraction. So that would be x squared plus 2 all over 6. And then I would do the reciprocal to both sides. The sign would stay the same. So the reciprocal, and notice that belongs to all of it. So be careful with the distributing. So when you do the reciprocal, it's just y minus 2 over 1, but it's negative in front. And that's going to distribute to make that a plus 2. On this side, when you do the reciprocal, it's 6 over x squared plus 2. To get y by itself, this is going to be negative y. So probably the best thing to do is to add y to the right side to get it by itself. A negative and a negative makes it positive 2. And then you'll just subtract this fraction to the left side. So do some quick algebra to get it by itself. And you just found the particular solution through that point, 0, 1. Perfect. All right. So I'm proud of you that, or 1, is it 1, 0? 0, 1. 1, 0. 1, 0, right? Yeah. So this is through the point 1, 0. Anyways, I'm proud of you. You did your work with me. It didn't take that long. But you chose to do a little bit of calculus every day, and I'm proud of you for doing that. Mr. G Math over and out. And, of course, until next time.